Good morning to all. Today I am continuing the second part of the video lecture, that is regarding the Newton ring. In this video lecture, I will discuss the experimental setup of the Newton ring. Let us start the Newton ring experimental setup. Please look this experimental arrangement which has been drawn in this diagram, where S is a monochromatic source, this one, which is capped at the focal length of a convex lens L, and we have a glass plate which is inclined at the 45-degree to the horizontal, and we have a Newton ring assembly in which it consists the plano-convex lens, that is A dash A, this one. This is the plane surface of plano-convex lens, and this is the curved surface of the plano-convex lens, that is A dash, and this is the glass plate. While it is resting on this glass plate, it has a contact point C, and a air thin film is enclosed between the plano-convex lens and the glass plate. And we also have a microscope. In this microscope, we try to look the Newton ring pattern, which is formed under the process of energy redistribution. So let us start how it works. This point source of monochromatic light, which is emitting a wavelength of lambda, capped at the focal point of this lens, generates a spherical wavefront, this one. And this spherical wavefront will convert into a plane wavefront by the lens L. And this plane wavefront, which incident on this glass plate at the angle of 45-degree. What will happen at the glass plate? The incident plane wavefront divides into the two wavefront, that is, one is called reflected and second one is called the refracted. Refracted wavefront, that is 2, goes to microscope and help us to view the Newton ring. And while the in plane wavefront 1 falls over the Newton ring assembly normally, so the incident angle is 0, and therefore it travels in through the lenses and the air and then glass plate. There the multiple reflection and refraction takes place from the upper and lower surface of this air thin film, wedge shaped air thin film, and it reflect back as the 1 dash and 1 double dash, which are going to superimpose and generates a plane wave generates a Newton ring pattern, that is interference pattern. So, and it appears as, in this assembly we are observing the interference due to the reflected light 1 and 1 dash, which generates a interference pattern of concentric rings. Centers become dark, and alternative bright and dark range rings are to be there with increasing diameter. Now I wish to talk about the certain findings. Now, in the superposition of the reflected part of light from the air thin film, it results in interference pattern which has certain observations. Observation number one, it is a concentric alternative bright and dark rings pattern. Second, the diameter of bright and dark ring are increasing as the order increases. Third, the spacing between the successive ring decreases with increasing order. Fourth, the rings at the peripheral of the pattern overlap. And the last, fifth one, the cross section area of the ring is remain constant. It is also independent of the order of fringes. And this point is very important to understand the sorry this point is very important to understand the phenomena of interference. I will brief out all the information which has been observed in the interference pattern due to the reflected light from the Newton ring assembly in detail in the next lecture. And I will advise all of you, please go through the any standard book and find the diagram and try to understand under this observations. For this lecture, I am in closing. I am also suggest you to rewrite the observation for the transmitted part of the light. Probably we have certainly the center of the transmitted pattern is bright. Thank you all.